And now, an exclusive sneak preview of a recent X-Talks webinar, Underground Stormwater Management using Geocellular Systems.
So this goes through the life cycle of stormwater management here. We've got our collection phase on the left side of the screen, going through some pre-treatment prior to entering our stormwater management systems, whether that's the stormwater management pond you see in the top left, or one of the three examples of underground stormwater management that you see on the right side of the screen. I'm going to start with a system that's kind of gray in between the yellow and the stormwater management pond. That system is either a corrugated metal pipe system. Also, it can come in the form of a precast concrete pipe system. Other systems in this category include cast-in-place or precast concrete tanks. These systems typically have a high void ratio. And when I say high void ratio, I'm talking about the percentage of space in that system available for stormwater storage. So higher void ratios equals lower excavation in those systems. They're very structurally sound, but they can be costly to purchase, deliver, and install. So that led to some innovation in the realm of thermoplastics, which you see in the bottom right of your screen. So some common thermoplastic systems we see in the United States are the arch and stone system that you see in the top right of your screen and geocellular systems that you see in the bottom left. Now, those arch and stone systems are kind of the next evolution in underground stormwater management. They typically consist of a thermoplastic arch or pipe that includes an open graded stone backfill, and both the stone backfill and the pipes or arches themselves are used for stormwater storage. Because we're using the net void ratio between that aggregate and the pipes, you tend to get a little bit of a lower void ratio for stormwater storage in these systems, so you need a little bit of a larger area to manage the same amount of water. So that leads us to geocellular systems. So what is a geocellular system? To put it kind of simply, they're individual cells which are assembled on site to form your stormwater management tank. These cells can vary in structure, materials, and properties ranging from void ratio to vertical and lateral strength, as well as water delivery. They've been in use since about the 1980s, starting with the honeycomb tank. So the honeycomb tank and corrugated metal plates, we see an example photo on the right side of your screen. This is going through some vertical compressive strength testing, and we see a cross section kind of gives you a sense of where the honeycomb tank got its namesake. So these systems are pretty strong under vertical load, but they're pretty weak under lateral load. They're commonly made of a polypropylene, and they feature one-dimensional water flow. So they're really flowing along the alignment of these honeycomb cells. In order to transport water around the tank, they'd use perforated pipes and gravels to help distribute throughout that tank section. Because you're dealing with this one-dimensional water flow really along the alignment of these tubes, you have some minimal access for inspection and maintenance. So the next evolution came in the form of plate systems. You can think of them as like a rectangular prism, so six-sided cube. So they were second to the market. They did have some issues with structural stability when they were first introduced, but they were adding reinforcing plates internally to these structures, which you can see in the photo on your right, to help kind of deal with some of those structural stability issues. This resulted in a system that was both strong vertically and laterally. We're still using a polypropylene material in these applications, but now we're introducing three-dimensional water flow. So these are perforated on all sides. It allows water to really take the path of least resistance and really flow throughout that tank. These cells are still somewhat isolated though, so inspection and maintenance become somewhat of a challenge. And that takes us to injection molding. The first generation of these were kind of colloquially called milk crates. You can think of them visually as what you see in the grocery store, but a whole heck of a lot stronger. We still have some isolated cells in this instance, so we still have limitations for inspection and maintenance. But as injection molding continues to evolve, we're starting to see a lot more non-isolated cells or a building block approach. You see a current gen system in the bottom right. The cells are highlighted red to show kind of the interlocking nature of those cells, as well as an open cell structure, so removing isolation from these systems. Because we're using injection molding, we can play with geometry to really introduce more strength both vertically and laterally. And we're also seeing a lot more diversity in the materials used. So we're still using a polypropylene, but we're introducing polyethylenes, recycled polymers, and blends of others. We're maintaining that benefit of three-dimensional water flow throughout your tank, but because our geometry is varying quite a bit, we're seeing a variance for access and inspection and maintenance.
To view the entirety of this webinar, visit the link in the description and register on xtalks.com completely free of charge.